So before I close this battery up, I want to show you what I'm doing here. So this is the old battery management board. Um, so this battery has, sorry about the noise, I have another battery charging. This board has all these MOSFETs on here, and they control the input and the output current from the battery. And as you can see, I blew two of them off. And well, I melted, they blew up. And I've removed them, hoping to get new MOSFETs for here. But the MOSFETs don't seem to be available or not easily gotten. I found a listing for them. They want $5 a piece for them. So if I fail any more of these, it's gonna be $10 to fix this thing. So I would look for another solution. This board is available. I could buy this board from China, but it's $25 and it has to come from China. But this is the proper one for these batteries. But what I managed to find was this board, actually. Yeah, so I found this board. I bought 4 of them, right? So they were $20 a piece. And I'll show you what I have, what this is. So on one side of the board is the power in from the battery, like on this pad. And on this side is the power out to the case, the outside of the case for running it. And you have these 4 wires here. It actually needs to be 5. Here's the 5th one. When you charge a lithium polymer pack, and if you look down inside here, there's a whole bunch of stacks of battery cells in here. Each cell needs to be monitored while you charge it. They need to be balanced. So this is made up of, I can't see exactly how many, but I think there's 12 of these packs in here to give 12 volts at 20 amp hours. And each one of these wires here, the yellow, the blue, the white, these ones go down and monitor the packs. They go down, way down inside here. So I need to, and of course the connector is different on this board than it is on the old board. So I need to take these wires, hook them into those wires. Luckily they're labeled here, battery 1, battery 2, battery 3, battery 4. And then once I do that, then this battery pack I think should be fixed. Hook it back up, put the top on, weld the top back on, plastic weld the top back on. And hopefully this battery will be up and good to go again. I've upgraded a little bit. This was 80 amps. This would handle 80 amps, and these new ones handle 100 amps. So I'm not sure whether it's 100 amps of discharge. I think it's probably needs to be more than that because they label this a 650 cold cranking amp battery. And it needs to start a machine. Well, it's supposed to start a motorcycle. So I don't know. Maybe they assume that a motorcycle will only need 80 amps to start. It seems low to me. I'm wondering whether it's 80 amps of charging, but 80 amps of charging is a lot for this little battery. So I hope they don't mean that the maximum that this battery will put out is 80 amps at a time. Now what I'm going to do, I'm going to go into the speed controller settings and bring the maximum amperage down to 20 or 30 or 40 to start. I don't know how many amps it takes. The thing died before I even had a chance to measure it. I have a new watt meter, ammeter watt meter. Can I get this open? No, it's taped shut. So I have this. I'm going to put this back on top, and then I'll be able to see how many amps it takes to drive this thing. And hopefully I can keep the amp limit down to 20 or 30 amps, and this should handle all of that, no problem. The problem is with when I took it for a drive last time, I had it cranked up to maximum, and I think when it regened, it blew this board out, blew these MOSFETs out. So I just wanted to show you the inside of this battery before I put it back together. I got to get everything all hooked up. There's lots of soldering here. All these wires are very live. That's why they're taped up right now, so I don't bump into them when I'm doing this work. I'll let you know. I'll know soon whether this is going to fix it or not.